Welcome back again. In previous section we gone through the basic configuration of PPP as well as a high level overview of PPP. So in this section we're going to take a look about PPP authentication. So in PPP authentication, which is CHAP and PAP, is a part of CCNP route. So the CHAP in PAP stand for Password Authentication Protocol, whereas CHAP stand for Challenge Handshaking Authentication Protocol. So let's see how does they work actually, and what will be the configuration. So the part of authentication is performed by LCP, which is known as Link Control Protocol. So it was the previous topology which we gone through the basic configuration. There was a branch router as well as HQ router. Since we are in lab, we have connected back to back without using any device which is known as CSU or DSU. So we do not have a CSU or DSU because we are connected in lab. I have a router which I am going to use. This is 2901 and running iOS is 15.2. So one of end of router need to execute clock rate. This is why I have executed the command clock rate. If you don't execute command clock rate, there is a default clock rate which is approximately I think 2 billion or 20 billion. I don't sure. I'm not sure about that, but if you're going to use default clock rate of interface, that not going to work. The rest of configuration is straightforward. You need to assign IP address, and a special command is encapsulation PPP. That is all about of basic PPP configuration. And so now let's go through the uh, PPP PAP authentication. So this is the topology, again same topology I'm going to use to perform rest of practical. But before going to perform rest of practical, I would like to show you. So my devices is up and working. I would like to show you the default encapsulation. So let's say this is branch router. So run section serial interface, or serial could be from capital letter. Yes. So I have actually 12800. So let's say first I would like to assign IP address, and then after going through the verification. So 10.10.10.1 255.255.255.0, no shutdown. Similarly on the next router, IP address 10.10.10.2 255.255.255.252, no shutdown. And let's check the connectivity. Do ping 10.10.10.1. As we can see, we do have a connectivity. So what I'm going to do, I'm going to use this interface, sorry, I want to make this interface as a default, which means there is no configuration. So the default information of interface as 0/0/0. Now it is default. So if we run the command do so run section serial or a serial, we will see this is the default clock rate. So if I'm going to assign IP address on it, interface as 0/0/0, IP address 10.10.10.1 255.255.255.252, no shut. We cannot send packet across the link, because if you see the link do so IP interface brief, your link is down. This is not because of the encapsulation, this is because of the incorrect clock rate. So that clock rate is not going to support it all. Because of that, I need to execute clock rate. So do so IP interface brief. You can also see on other router. So let me execute the clock rate. Excuse me, clock rate 12800. By the way, you can use one of them, use the question marks, and then after you have couples of way to select the clock rate, but I'm going to use 12800 for demonstration purpose. This thing going to perform, actually if you have a CSU DSU device, you don't need to execute clock rate on your router. This going to be execute on your CSU DSU device. But as I told you earlier, in my scenario, in my case, I do not using any CSU DSU device. Because of that, I need to execute clock rate on this interface. So that is good. Now the interface is up. Do so IP interface brief. And we can also send the packet to the destination device, which is 10.10.10.2 HQ router. Now the link is up. Similarly, we can verify right there. So the next thing which we going to discuss, we want to make this secure. We want to make this connection secure, I should say. So to make this connection secure, we can use PAP, CHAP, or MS-CHAP or EAP. So these are the mechanism available in PPP in order to make your link, your layer 2 link secure. So don't bother about that, because most of cases we think that, suppose if we are running any routing protocol like RIP or OSPF or something else, they also use authentication. So if we using authentication in routing protocols, it means if you are not trusted to me, I'm not going to share my routing table to you. Similarly, headquarter to branch. If uh, both router configuration is not identical regarding password, they are not going to share their routing table. But in case of PPP, this is something different. So make your link up. You need to be the right person, which means are you the right person to be connect with this link? To make link up, you need to go through the authentication to ensure that the right person is connected to the second link. So because of that, we using PPP authentication using CHAP or PAP. So next thing, let's discuss something about PAP. PAP stand for plain authentication protocol, plain text authentication protocol. Oh, sorry, PAP, plain text authentication protocol, or password authentication protocol. So sometimes it's known as password authentication protocol or plain text authentication protocol as well. So this is the initial way to use authentication inside your devices in order to verify the appropriate device connectivity. So let's see how will be the configuration if we going to use PAP. So one of router going to be a requester, which is going to request, and another router going to be a responder. So responder basically maintain a username and password on their running configuration. A requester coming to you and requesting, I want to make this link up. And on the particular interface, you need to execute command PPP PAP. I want to send my username Aditya and my password is CISCO. So this matter going to send using this interface a direction of headquarter. Now headquarter going to verify Does I have the same username and password or credential which you sending? If yes, let the link up, else not. So this is what one of router going to be request for this, and another router is going to be check it out. That's why it's known as single way handshaking authentication protocol. I think two-way or a single way. I'm not sure actually. Which is, you can say, the one direction verification going to be. But in case of CHAP, challenge handshake authentication protocol, this is going to be three-way handshake authentication protocol actually. We'll discuss shortly about CHAP. So first let's discuss about PAP. So let's go through the configuration. On interface encapsulation PPP, you can select which one going to be the requester and which one going to be the responder. In my case, I'm going to use my headquarter as a responder and my branch router as a requester. So the configuration is straightforward. Let me fix my window a little bit to make both thing visible. So from headquarter on serial interface PPP authentication, we're going to use PAP. So this is the authentication which we want to from headquarter. As well as I also need to maintain a username and corresponding password of that user. So in this case, I'm going to use username Aditya. You can put anything which you like, and then after password, I would like to keep CISCO. Too simple. So as we can see, do so IP interface brief. This is the alias. Your link is down because of the authentication. We'll discuss shortly all about the authentication. Authentication troubleshooting or debugging. On this interface, which is serial 0/0/0, here I need to use PPP, and then after PAP, I would like to send database, which is username. Let's say one more thing I should discuss right there. Your username is not a case sensitive, but your password is case sensitive that you need to know. So no matter you are using block letter of A or a small letter, but your password should be same on both ends. So again, I would like to verify that thing. So as we can see, the username, I'm going to use a block letter Aditya, and then password, I think what I have created right there, it was the block. So let me make this small letter Aditya, and then password will be identical, which is CISCO. So I'm going to send, my username is Aditya, and then password is CISCO. Now we can see our link is up. Do so IP interface brief. Let's verify this, and also going to send the packet that we can see we do have a connectivity. So this is quite easy to understand, but the concept is little bit weird. I find that in most of cases when we using authentication, we maintain means, as we can see on this interface, we have executed command PPP authentication PAP. So suppose same command if you're going to perform on this interface, that may not going to work at all. So make sure your configuration is regarding PAP. What you do, regarding PAP, what you going to do. Now this is time for CHAP or Challenge Handshake Authentication Protocol. So in PAP, let me discuss a little bit more about PAP. In PAP, your username and password, which is going to send through your serial interface, is in plain text. So maybe someone can grab your information and they come to know, your opponents come to know what is username and password of this link. Since this is going to send on plain text, that is not going to consider a security. For security, there should be some kind of encryption so that opponent cannot guess what is username and password of your link. So in order to do this, we need to use CHAP or Challenge Handshake Authentication Protocol. So in CHAP, both router going to maintain their database. So that's why it's known as three-way handshaking authentication protocol. So let's say branch going to maintain headquarter username and password. So suppose username going to send, hey, I am HQ and my password is blah blah blah. So now branch need to verify, okay, you are HQ, your password is Cisco. Welcome here. From my perspective, you are the right person. But what about me in your perspective? I am the branch and my password is Cisco. So that thing I'm going to send over the serial link. Since headquarter have the same database maintaining, which is username and password. So now we can form our layer 2 link up. Else, if something went wrong, we don't. So this is what, but the difference is between PAP and CHAP is that in CHAP we are not going to send any username and password. We are going to send actually MD hash. I think it's hash value. So we're going to send the hash value, whatever hash value generated after the configuration, and similarly whatever the hash value generated by the headquarter. So both their router going to match their hash value. If value is identical or a same, then after they going to form the link. Otherwise they cannot. So this is what difference between PAP and CHAP. So first I would like to go through the basic CHAP configuration, and then after verification, and then we have another way to configure CHAP. So let's go through the basic configuration first. First of all, no authentication. So this is no PPP authentication. Similarly on headquarter interface 0/0/0, no PPP authentication. Excuse me. So we are not using authentication. Now I'm going to apply authentication, PPP authentication, which is CHAP. Similar on headquarter router, PPP authentication, authentication CHAP. The next thing which we need to do, we should have to have username and password on both router. If we do not going to create username and password globally, again we cannot form the layer 2 link up. Otherwise we can negotiate, let's say debug PPP authentication. So before I let you show the PPP debugging, I highly recommend you follow the link which I'm going to share below the video, YouTube video. Understanding debug PPP negotiation. So there is all about debugging. Like what you need to know in order to, first let me turn it off. You all, which is undebug all. What you need to know, you don't need to be the master of every debug command. Means whatever is you can see the debugging output we getting. in your console window. You don't need to be the master on it, but at the end you should come to know what is the problem behind the scene and how you can going to fix it. So the first phase you are going to perform by PPP negotiation. So this is the phase and this is the description: down, establish, authenticating, up and terminating. And these are the abbreviation going to use like LCP, CHAP, PAP and NCP. And let's say this one. Actually this one make sense to understand how does PPP going to make their link up. So suppose your link was earlier down. So you connected to your destination router or remote router. So link going to up. So they're going to perform establish the link. If you are not using any authentication or password, after establishing, your link going to be the up. So down to establish and then after up. If you are not using any authentication or nothing went wrong with your interfaces. Suppose if you using CHAP or PAP, this is task of your LCP again, link control protocol, whatever authentication you using. It could be challenge handshake authentication protocol or plain text authentication protocol. Say they going to the phase of authentication to verify the identical information of both router. If authentication is success, your link going to be up. If something went wrong in your authentication, this is going to terminate and again going to initiate, means again and again you trying to send the username and password, and every time it going to be terminate. So because of that, let's say, suppose if your first step is going to fail, you will wait a predefined time, again you sending the same username and password whatever you have configured on this router, again going to authenticate, and this is going to be frequently sent over the link until you're not going to fix. So once you fix this authentication parameters or configuration which is identical on both routers, then after they are not going to negotiate until the link is down or something went wrong. So suppose if something is everything is fine, then after the link you are going to be the up. The next thing, on PPP negotiation we have couples of packet and their code and description. So as I told you earlier, you don't need to be the master of every line, but you should have at least the basic troubleshooting way, so that you come to know what is wrong going inside your network so that you can fix it. Next thing, your LCP authentication and NCP stage. So let me discuss a little bit about LCP authentication and NCP stage. So everything is mentioned right there. So LCP is mandatory phase. It's supposed to be run every time. And at the end, NCP and then troubleshooting. Reading the debug PPP negotiation output. There will be the time step, interface type of messages, direct of message, message ID and length. Yes, this is the output which we can see when we debugging the PPP. So this is timestamp or of millisecond. So whatever is going within a millisecond, which is you can see on your console window. So this is the interface where we using a negotiation on it, and then stage of negotiation, and where is I stand for, this is the incoming packet. So suppose if you have a two router, whatever message you receiving, you will find there will be I. In whatever you're going to send, there will be O. So you can say the incoming or outgoing packet. Then whatever is message, field ID and length of it. This is true. You can see it when you're going to debug it. So rest of things, as we can see, this is all about where we have a very good link going to share to you. I'm going to share with you as well the physical layer, and then after establishing LCP negotiation, incoming confirm, which is using I, and then after this is optional. If you are not going to use any authentication, this is not going to show. If you using any authentication, then after you can see this. So authentication protocol, the value is PAP, CHAP or something else, and then magic number. So this is used to detect loopbacks and always send over the link actually, and then call back. Similarly, the rest of things. So I'm not going to every line, but now we have a basic idea about their authentication. What is authentication protocol value? What is a magic number? Why it going to be used? Which is the incoming packet? Which is the outgoing packet? And at the end, do we have everything is correct? If LCP is open, which means now everything is fine in case of LCP. So once your LCP perform the task, now it's time for NCP to negotiate what kind of traffic or what kind of layer 2 or layer 3 information going to send with. So let's see. So your CHAP again performed by your LCP, successfully authentication. In the next task, here we can see now the PP is up and NCP going to negotiate. So negotiation begins right there. We want to send IPv4 packet, CDP packets in layer 2, IPv6 packet or something else. So this is task of your NCP. As we can see, the Cisco discovery protocol and all those things. In the end, we going to install a root. So whatever the IP address of destination device, which we going to install on it. So come to the configuration again. Similarly, we can see here. So start from right from the beginning using default call direction. So this is incoming packet. So incoming packet we receive from, sorry, this is the outgoing packet because we are working on HQ router. See, so this is my host address which I am going to send. One more thing I should also mention about that. So by default, actually your host name going to be the username. So at time of authentication, by default, whatever your host name is assigned on your router, this is going to be the username. That's why branch router maintaining the username, whatever username of this router is. Similarly, on whatever is host name of this router is going to be the username, a database of your headquarter router. So this is true every time if you are not going to change the default behavior of it. So as we can see, our outgoing message from pod 1 HQ, this is name of my router actually, where we have turn on debugging, and incoming we receive this one, and send CHAP authentication request, and receive the authentication request is failed because we didn't use any kind of username in password, so unable to authenticate for peer. So again and again this is going to happen again and again, as we can see. So let me configure this. So username, whatever is host name of this router, which is, let me copy that, and then after password. So let password is Cisco. Similarly on this end, username, this is pod 1 HQ router, copy, paste, and then after password is Cisco. So what we expecting now, our link supposed to be going to up if we have a identical configuration, and as we can see, yes, we do have. So do so IP interface brief. Now our link is up, and let's check the connectivity to sending a ping packet. Yes, we do have connectivity. So we can use the configuration. This is the simple way. Either we can also use the another way in order to authenticate using the challenge handshake authentication protocol or a CHAP. So now this is good if we have a one router. Suppose from headquarter we have couples of more router connected, and we don't want to send same username out every link. We want to make the different username on every link and different password on every link. So on that way, because if you're going to create on simple way, your host name going to be the username. So suppose if you have a multiple remote site and you want to make the different username and password, in such case you can use such kind of configuration. As I told you earlier, by default your host name going to be the username of the link, and whatever password you're going to apply should be identical on both of end. So let's say if we decide we don't want to send the default host name over a link, so what we can do? On interface basis, we can execute one more command, PPP CHAP, and now my host name is left. Suppose, since this is my left hand side, this is my right hand side, I make it simple to understand. In your case, you can change whatever name you like to do. You like to keep actually. So in my case, PPP CHAP and host name is left, and similarly PPP CHAP host name is right. So I'm not going to use my default host name. Now I'm going to use host name as a right in order to authenticate. So make sure whatever username you're going to send over the link, that should have the entry of the destination router. So as we can see, right coming to me, so I have the database of right. Left coming to the me, so I have a left database inside my global configuration. So make sure this should be available. So the interface is 0/0 and so on and so forth. Before going to configuration, I would like to show you once again debugging. So debug PPP, not PPP authentication, actually I'm going to use authentication, and let the bring down and bring them up. So shut the interface, and then after no shut, and let's say there we go. So as we can see, the default username is pod1 HQ and pod1 branch. This is going to send across link. So what happen if we going to change it? So let me change the, again, no PPP authentication which we going to use. Similarly on this interface or other router, no PPP authentication, And similarly, do so run section username. I'm going to delete username as well. So no username, bye bye. No username, this one. And let's say, let verify. Yes, we do not have a username since I have deleted. Similarly, do so run section username. So no, and then after whatever is username we using. So this one, and I think this need to be executed on interface basis. Yes. So again, let me execute command do so run section interface. On serial interface, let me use no actually. So interface s0/0/0 no. You can use both of it. So means PAP and CHAP you can configure at same time. If PAP going to fail, then CHAP going to work, and CHAP going to fail, then PAP going to work. So you can configure both of it. So now what I'm going to do, I'm going to use the other way to configure the CHAP authentication. So let's say on interface s0/0/0 PPP authentication, I'm going to use CHAP. In PPP CHAP, my host name is now left. So this is branch router. Now my host name is left. And similarly on headquarter interface s0/0/0 PPP authentication CHAP, PPP CHAP, my host name is right. Next thing, we need to maintain each other database. So from branch router, globally username right. So your headquarter going to send actually right username. So I need to maintain username right, and then after password, whatever password you like to keep. Likewise on other router. So username, it was left, I think. Yes, it was left. Username left, and then after password is CISCO. So now let's do the debugging again. So IP interface brief. Our link is up, and debug PPP authentication. Let me set the link. So hop over interface s0/0/0, shut the link, and bring them back up. Yes, as we can see right there. Now rather than using pod 1 branch and pod 1 HQ, now we are using right and left as a host name. so so this is what we can use another way of configuration when we using CHAP or challenge handshake authentication protocol. And rest of information I'm going to skip for this video, or for this series I should say. You can go ahead and follow the link given to the YouTube video below, and you can read out all over the things. So in this video, this is all about. In upcoming video, we're going to discuss about PPP multi-link bundling. So suppose PPP multi-link bundling, actually this is not part of CCNP route, but for bonus video I am going to create PPP multi-link bundle. So in this video, this is all about.